Hello once again, class, and welcome to another mock lecture. Today we're going to be talking about some fraction hacks. Specifically, there's one thing that I want to teach you that applies to three different cases of making fraction operations easier to do. We'll talk about common denominators, we'll talk about simplifying, and we'll talk about multiplying, which also will talk about division since you just flip and multiply. All right, so we're going to go through these three things, and let's get started. All right, so here's the intro example. We got 13/24ths, and we're going to add that to 7/18ths. Now, a very common strategy among students is, well, hey, a common denominator can be found by just multiplying 24 with 18. I don't want to think about doing that. I don't know what 24 times 18 is off the top of my head, so I usually don't go for this strategy. Another common one is you look for the multiples of each denominator, and then you find, well, when are they the same? But that's also a lot of work, and so I don't want to do that either. Or what you could do is we could use factor trees. So what is a factor tree? Well, let's start with 84, right, as an example. Let's say I want to find the factor tree for 84. Essentially, what you're doing to find a factor tree is you're factoring this thing into its factors. There's got to be a better way to say that. You're breaking down the number into its individual factors. I see that 84 is divisible by 2 because it's an even number. So I'm going to take out a 2, and if you do that, you end up with 42. So we've begun the factor tree, right? 84 breaks into 2 and 42. Well, 42 is also even, so that breaks into 2 as well, 2 and 21. 21 breaks into 3 and 7, and here we go. This is our factor tree for 84. In fact, this is actually a prime factor tree because all of the factors that I broke it into are all prime numbers. 2, 3, and 7, right, are all prime. And it's called a factor tree because it kind of resembles a tree. Isn't that cute? So by way of factor tree, we know that 84 is 2 times 2 times 3 times 7, right? Those are the individual factors, the ends of the branches, as it were. Those are the factors of 84 here. And by the way, your factor tree might look different than mine. Like maybe you see that 84 is divisible by 4 at the beginning, and 4 times 21 is 84. And then the 4 breaks up into 2 and 2, and the 21 breaks up into 3 and 7. But you'll notice that the same factors comprise the number. So there's a lot of ways that you could make a factor tree, but they're all going to give you the same factors, right? Especially if you go down to prime numbers. All right, so back to this. We've got 13/24ths plus 7/18ths, and what I'm going to do is I'm going to make the factor trees for 24 and 18. And the thing I'm going to notice is that these things already have some factors in common. Namely, they already both have a 2 in common. They already both have a 3 in common. And so when I'm finding common denominators, I ask myself the question, what is missing from this factor tree that this one has? And it's just the 3. The only thing that the left factor tree is missing is the 3, and so that's what I'm going to multiply on the left-hand side. And so now they both have that second 3 in common. For the right-hand side, again, what's missing here? What's missing on the right-hand side that the left-hand side has? Well, it's both of these 2's. And so that's what I'm going to multiply by on the right. 2 2's. Now they both have those 2's in common. Or we could simplify that to being 4 and say, oh, no, they both have a 4, right? They both have that 4 that's in common. But so that's going to be our common denominator. It's whatever 3 times 24 is, which is 72. But that's the same thing that we're going to get when we multiply 18 by 4 as well. So our common denominator then is 72. For the numerator of that first fraction, we had 3 times 13, that's 39, right? This multiplication gives me this number. And then 7 times 4, right? That's 28. And then we just add those two things together and we're done, right? Here's another example, 5/28ths plus 11/12ths. All right, so again, factor tree stuff. 28 breaks into 4 and 7, 12 breaks into 4 and 3. They already have a 4 in common. You could go to the 2's. You can be like, oh, well, these both break up into 2. But once you find a commonality, you're done. You don't have to keep breaking down that particular number. And they both have a 4. The thing that's missing on the left is the 3. Now they got those in common. The thing that's missing on the right is the 7. Now they got those in common. So it looks like our common denominator is going to be 84 because 3 times 28, which is the same as 12 times 7 is 84. And then we add those two things together. We get 15 plus 77 84ths, which is 92 84ths. Now you might have noticed that 92 84ths actually simplifies, right? They're both even numbers so that we could at least divide things by 2. But here's another use for factor trees. If we make the factor tree for 92 and 84, anywhere that we find the number that's the same in the numerator and the same in the denominator, those cancel. The numerator and the denominator both have a factor of 4, right? They have 2 2's in common. So I canceled those out, and then we look for what's left over. Well, in the numerator, there's this 23 that didn't cancel with anything. And in the denominator, we've got this 3 and the 7, which is 21. So that's the thing on the bottom. So 92 84ths is the same as 23 21sts, right? By way of factor tree. Super easy way to simplify. And the last quick thing I want to cover is multiplication, right? 10 21sts times 14 15ths. The most common thing that I see students do is they'll just straight up multiply straight across, right? 10 times 14 over 21 times 15. You're going to get something, and I don't know what 21 times 15 is off the top of my head. But then you can simplify by doing the exact same thing that we did, in the last section. Or we could make factor trees, right? 10 is 2 and 5. 21 is 3 and 7. 14 is 2 and 7. 15 is 3 and 5. When we multiply straight across, all of these factors are going to be in the numerator and all of these factors are going to be in the denominator. So if I see any pair of numbers that's in top and bottom respectively, I get to cancel them, right? These 5s, those are going to cancel. These 7s are going to cancel. You're going to be left with these 2 2's in the numerator, which is 4, and these 3's in the denominator, which will be 9. It works for division as well, because all you have to do is flip and multiply that second fraction, right? Now the operation has changed from division to now multiplication. So again, we make factor trees, and anywhere that we find pairs of numbers that appear in numerator and denominator respectively, we get to cancel them. So the 10s, the 3s, the 7s, the 11s, these all cancel, and you're just going to be left with a 3 in the numerator and a 28 in the denominator, and that's it. All right, so I hope this quick video was helpful. Factor trees are super simple. If you guys have any questions, please shoot me an email or leave a comment below. Thanks a ton for watching, and I'll see you in the next one.